Hi everyone, in this video I'm going to be showing you guys how to graph sinusoidal functions. So the image on the left is the graph of the sine function. As you can see, the distance from the center to the maximum height is the amplitude. Similarly, the distance from the center to the minimum height is also the amplitude. So think of the amplitude as basically half of the height of the function, or maybe the radius of the function. Now, a period is the distance it takes for a function to complete itself. So for any function that repeats itself, there's going to be a value that repeats over and over and over again. So this period is measuring how long it takes for a point to basically come back to itself. That is one period. Now, in a cosine function, it's very similar. A cosine function has all the same elements. It has an amplitude, it has a period. The only difference from the sine function is that it's basically shifted over one increment, which is why it starts at 0, 1 and not 0, 0. So that's basically sine and cosine functions. And as we go along, we'll see that sine and cosine functions, every single function under this family looks pretty much the same. The only difference is the increments, the period, and the amplitude. So those elements are going to be different for each one. Now, when we're graphing a sine and cosine function, where we come across the general form, y is equal to a sine bx and y is equal to a cosine b of x. Now, the first thing we want to do is to find the amplitude. The amplitude, again, is half of the height, and we find it by taking the absolute value of a. A is the value or the constant in front of the function. Now, we then find the period, which is going to be 2 pi over b. So b is the value inside of the parentheses. Now, we have our amplitude and our period, but that's not enough information to actually graph the function. So in order to plot enough points to actually figure out the shape of the curve, we have to multiply t, or the period, by 1/4. So multiplying the period by 1/4 determines the intervals. So going back up here, the period was the period of this graph was up to 2 pi, but we have 4 intervals in between, which is basically what we're finding when we're multiplying the period by 1/4. Now, before we move on to some examples, I want to show you guys some acronyms that may help you memorize this a little bit better. So, for sine function, we have the acronym IMImI, which stands for intercept, maximum, intercept, minimum, intercept. And then for cosine function, we have the acronym MImIM, which stands for maximum, intercept, minimum, intercept, maximum. Now, you'll see how we'll apply this to our examples later on. Okay, let's move on to our first example. So this example is y is equal to 3 sine x. So the first thing we gotta do is we gotta find our amplitude. So remember that our amplitude is the absolute value of a. A in this case is the absolute value of 3, which is just 3. So our amplitude is 3. Now let's find our period. So our period is 2 pi over b, and b is the constant inside of the parentheses, which is just 1 in this case. So it's 2 pi over 1, which is just 2 pi. So that is our period. However, we need to find the increment of our graph, how we're going to divide up our period. So in order to do that, we gotta find 2 pi times 1 over 4, which is pi over 2. So pi over 2 is our increment. Now let's actually make this into an xy table. so we can visualize or see our points better. So whenever we're asked to graph one period of a graph, you're basically only plotting 5 points. You start at x equal to 0 and you end at x equal to your period, which is 2 pi in this case. And then in between are your increments. So pi over 2, 2 pi over 2, which is pi, and then 3 pi over 2. Those are our x values. And then for our y values, you can put your x values into the function and solve for the y values manually. However, that's tedious and not very convenient. So what we can do is use our acronym. So this is a sine function. So we're going to be using the IMImI acronym, which is intercept, maximum, intercept, minimum, intercept. So our intercept is going to be 0. As you can see, our intercepts are at 0 all over here. And then our maximum is going to be the positive amplitude. So our positive amplitude is 3. And then minimum is going to be our negative amplitude, which is negative 3. So let's actually plot these points. We start at 0, 0. We move on to pi over 3, pi over 2, 3, pi, 0, 3 pi over 2, negative 3, and then 2 pi, 0. So this is one period of the graph. If you were asked to find 2 periods of the graph, you would just continue the pattern in any direction. So here I'm going to go backwards. So I'm just going to continue the pattern. It's pretty easy to visualize from here on out. So this is 2 periods of the graph. So again, this is one period, and then this is another period. Let's move on to another example. So for this example, we have y is equal to 2 cosine 4x. So as always, we start off with our amplitude. Our amplitude is going to be the absolute value of 2, which is just 2. Then we find our period, which is 2 pi over 4, pi over 2. That's our period. But that's not enough information to actually graph the function. So we gotta find our increments. We do that by dividing our period by 4, which is going to be pi over 8. So pi over 8 is our increment. Now we take this over to our xy table. Again, we are graphing one period of the function, and so we have 5 points we're going to graph. So we start at 0, and we end at our period, which is pi over 2. And in between are our increments, so pi over 8, 2 pi over 8, which is pi over 4, and then 3 pi over 8. Now that we have our x values, we got to determine our y values. We do that by using our acronym for the cosine function, which is MImIm. Maximum, intercept, minimum, intercept, maximum. Maximum is the positive amplitude, which is 2. Intercept is 0. And then minimum is our negative amplitude, which is negative 2. So now we gotta plot this on our graph. Okay, so the first point we have is 0, 2. Second is pi over 8, 0. Pi over 4, negative 2. 3 pi over 8, 0. Pi over 2, 2. So this is one period of our cosine graph. And then if we were asked to find 2 periods, we would just continue the pattern in any direction. And so this is one period. Before we move on to some more complicated examples, I want to go over an important rule. So we use the IMImI and MImIM acronym so far, but it's important to note that when we encounter a negative function, so a negative sine x or a negative cosine x, we are essentially flipping the function across the axis. So we are making an x-axis reflection of the graph. In doing so, we are flipping the minimum and the maximum values of the graph. That means that we can't necessarily apply the IMImI and MImIm acronyms directly, we gotta flip it. And so IMImI for the cosine graph, if we have a negative sine x graph, it becomes IMImI with the minimum and the maximum values switched. Same thing for the negative cosine graph. We swap the minimum and maximum values, and that becomes minimum intercept, maximum intercept, minimum. And so note that if we have a negative in front of the function, we gotta swap the minimum and maximum values in our acronym. And now it's also a good time to review our even and odd properties. So whenever we encounter a negative inside of the function, so inside of the parentheses, we gotta refer back to our even and odd properties. So odd functions include sine, cosecant, tan, and cotangent. And basically for odd functions, if we have something like sine negative x, we can basically pull that negative out in front of the function, so that becomes negative sine of x. And there you would use the rule here where you flip the acronym. However, even functions include cosine and secant. Those are the only even functions. For these ones, if we have something like cosine negative x, we can actually cancel out the negative. We actually ignore the negative. So cosine of negative x is actually equal to cosine of just x. And so be very cautious of this. Just because it's cosine negative x does not mean we swap the acronym. Only when the negative is outside of the function does this rule apply. Okay, let's move on to a more complicated example. So here we have y is equal to 3 times sine negative 1/2 x plus 2. So the first red flag, sort of, is that there is a negative inside of the function. That is not ideal. You want to take out all negatives inside of the parentheses. So here we have a sine function. We know that that's an odd function. So that means that f of negative x is equal to negative f of x, according to the property we just listed. And so this is actually equal to negative 3 sine 1/2 x plus 2. We're going to be using this version of the function to guide our graphing. So first, let's determine our amplitude. So our amplitude is the absolute value of negative 3, which is equal to 3. And then our period is equal to 2 pi over b, which is 1/2. That's equal to 4 pi. So that is our period. However, again, that's not enough information to graph the function. So we gotta find our increments by dividing our period by 4. So our increment, we are incrementing by pi. Okay. So let's actually plot these on our XY table. Again, I'm using 5 values here, starting from 0 to 4 pi, which is my period, and in between is my increment. So pi, 2 pi, and 3 pi. We have our x values. Now we got to determine our y values. So we are dealing with a sine function. So that means that we're going to use the IMImI acronym. However, this is a negative sine function. According to our rule here, if we have a negative function, we are swapping the minimum and maximum in our acronym. So that means that we are going to actually use the acronym intercept, minimum, intercept, maximum, intercept. So before we go on with our y values, however, another thing is that we are adding 2 to our function, meaning that we are shifting our entire function up 2 units. That means that whatever y values we determine here, we're going to be adding 2 to the y values. So usually intercept is going to be 0, however 0 plus 2 is 2, so we're actually having the intercept of 2. our minimum values would be -3. However, we're shifting it up 2 units, so that's going to be -1. And then our maximum value is 3, but we're shifting it up 2 units, so that's 5. So here we have the x and y values for one period of the graph. Okay, so let's now plot the points. So first is 0, 2, pi, -1, 2 pi, 2, 3 pi, 5, and then 4 pi, 2. So notice that this is the same shape as our sine graph from earlier, except our increments are different, our amplitude is different, and we have shifted this function up 2 units. So that means that our y is equal to 0 is now y is equal to 2. So this is what one period of this graph looks like. Let's do one last example. So here we have y is equal to cosine -5x minus 1. So again, I noticed that there is a negative inside of the parentheses. Again, we don't want a negative inside of the function. So we gotta refer back to our even and odd properties. Cosine is an even function, meaning that f of -x is equal to f of x. Using this rule, we can rewrite this function into y equal to cosine of 5x minus 1. This is the version we're going to use to actually graph our function. Okay, so let's find our amplitude. So amplitude is going to be the absolute value of 1 because the constant in front is 1, and that's equal to 1. Our period is equal to 2 pi over b, which is 5 in this case. So 2 pi over 5, we're going to that's our period. We're going to multiply that by 1/4 to find our increment, and that's going to be pi over 10. This is our increment. Let's make our xy table. And we're going to use 5 values once again. So we start from 0 and then we end at our period, which is 2 pi over 5. In between is our increment, so pi over 10, 2 pi over 10, 3 pi over 10. And then we end at 2 pi over 5, which is our period. We have our x values. Now we're going to be using our acronym to determine our y value. So the acronym for cosine is MImIm, maximum intercept, minimum intercept, maximum. Now, some of you may be thinking that we swapped the minimum and maximum. However, remember that we have rewritten our function to become a positive function according to our even and odd properties. And so there is actually no need to swap our acronym. Now, before we go on with our y values, however, we are actually shifting our entire function down 1 unit. We're doing -1 outside of the function, so we are shifting it down 1 unit. That means that whatever y value we have here, we're going to subtract 1 from it. So our maximum value is going to be 1. However, we are shifting it down 1 unit, so that's becoming 0. Our intercept is usually 0. However, since we're shifting down 1 unit, it becomes -1. And then our minimum value is the negative amplitude, which is -1. However, we are shifting down 1 unit, that becomes -2. And then maximum is again 0. Okay, so let's plot the points here. So first we have 0, 0. Next we have pi over 10, -1. Next we have 2 pi over 10, -2. We have 3 pi over 10, -1, and then 2 pi over 5, 0. So here is our classic cosine function, except we have shifted it down 1 unit. And notice that what would usually be y equals 0, we now have y equals -1. So that is one period of our cosine function. So generally, I want you guys to note that the shape of all of these functions are the same. However, their interval and their amplitudes are different because they have different functions. Also note that if you ever get confused on what a period is basically a point that comes back to its original point. And so if you forget what one period is, just measure out when a point comes back to its original point. That's usually easier to do on a cosine graph. You start from this high over here, and then you only come back to that same level until when you finish that period. And so this is one period. So that's just another tip to determine a period. But hopefully this video helped you guys graph sinusoidal functions more quickly and efficiently. I will see you guys in my next video. Bye!